Hello everyone, my name is Adarsh Raj from F4 batch BTech CSCIML Techno India University. Today I will be presenting a video on the topic Infix to Postfix Notation Conversion, a key concept in data structures and algorithms. Here is my introduction. Here's what I will cover in this video. First, the difference between infix and postfix expression, then the algorithm used to convert infix to postfix, followed by the program implementation in C, and finally a look at the output. Let's begin with the notation types. First is the infix expression, in which the operator is placed between the operands. Example is a plus b. This is the most commonly used notation we generally use. It requires parenthesis and operator precedence rules for correct evaluation. Next is the postfix expression, in which the operator comes after the operands. Example AB plus. No parentheses are needed. Easier for computers to evaluate using stack. Now let me explain the algorithm to convert infix notation to postfix expression. First, we read the infix expression from the user, then initialize an empty stack for operators, initialize an empty string or array for the postfix result, loop through each character of the infix expression and skip spaces if it's a digit or a decimal, read the full number and add it to the postfix string. If it's an opening parenthesis, we push it onto the stack. If it is in closing parenthesis, we pop from the stack to the postfix until opening parenthesis is found. If it is an operator, we compare the precedence with the stack's top operator. If the current has lower or equal precedence, pop and add to the postfix. Otherwise, push the current operator onto the stack. After reading the expression, pop the remaining operators of the postfix. Finally, we null terminate the postfix string and display the result. Let's now walk through the program step by step written in C language. We start with the necessary header files like stdio.h for input and output, stdlib.h for memory allocation, ctype.h to check if the character are digits, stdbool.h for using boolean types like true and false. We define a structure stack to simulate our stack with top to track the top element index, size to store the total capacity, array as a dynamically allocated array to hold data. Then we have several functions. init allocates memory and sets initial value for the stack. IsEmpty checks if the stack is empty. Push inserts an element into the stack. Pop removes the element from the stack. Peek returns the top element without removing it. And precedence assigns precedence to the operators. Now comes the main function. We declare two character arrays, infix and postfix. We ask the user to enter the infix expression. Using fgetters, we take input and remove the new line character. Then we call infix to postfix to convert the expression. And finally, we display the output. Here is the function definitions of isEmpty, push, pop and peek as explained earlier. Now we have the precedence function, which returns the precedence of the operator. Next we have finally the infix to postfix function, which converts our infix expression to postfix notation. We initialize a stack using init, then we loop through the infix expression using index I and build the postfix string from using index j. For each character, if it is a space, we skip it. If it is a number or decimal, we keep adding it to the postfix string until it ends. If we find a opening parenthesis, we push it onto the stack. If we find a closing parenthesis, we pop operators until we get a matching opening parenthesis. If it is an operator, we compare it with the stack's top operator and pop accordingly based on the precedence. After the loop ends, we pop all the remaining operators from the stack. Finally, we null terminate the postfix string and free the memory used by the stack. This program follows the exact algorithm we discussed and successfully converts any valid infix expression to postfix 1. Let's look at the output of the program. As we can see here, when we enter the infix expression, the program correctly generates the postfix form. This confirms that the program and the logic are working as expected. That brings us to the end of the presentation. Thank you for watching.